Hello everyone. In this video presentation, I am tasked to explain the code behind the problem solution.
Let's start with the first problem. Linear search. Linear search operates sequentially, meaning it examines each element one by one in order. So the search method will look like this. The search will start at the index, and while the array still has an element, it will keep on looping and will only stop once the value inside the array is equal to the target value. Now if all of the elements in the array are checked and not one element equal to the target, it will return -1. This is the method for creating the 2D array. It will allocate the two parameters, rows and columns, since these two values are to be inputted by the user. Now, let's move on to the main function. Since it is highly reliant on the input of the user, I have put error handling in many of the inputs that are prompted to the user. Now let's explain the code sequentially so you know how your prompts look like in the code. First is the input for the number of test cases. This input will decide the number of loops for the program. Second is the input for the number of rows and columns. The values that will be acquired from the user will be stored in variables n and m and will then put as a parameter in the create2the_array function. Next will be for the elements for the array. The loop for this will be the number of rows the user inputs. The elements will be separated by spaces and will only take the elements if the number of elements in each row is equal to the columns the user inputs. Now for the searching, the user will be asked to input the element to search for. If the element is found, it will print the index for the row the element is located. Now that I have explained the codes, let's try running some examples.
Now that we have explained our code, let us now try to run. All the given sample inputs are based from the Leons. First, we have to input the number of test cases, which is 1. Then we have to enter the number of conveyors, which in this example, we need 3. Then we need to enter the length of the conveyor, which in this case has 3. Now, we have to enter the baggages for conveyor 1. Based from the sample input from the Leon's document, we are going to enter for conveyor 1, which is 101, 102, and 103. Next up is conveyor 2, which has the number of baggages 201, 202, and 203. And lastly, conveyor 3 has the numbers 301, 302, and 303. Once we are done inputting the number of baggages, we then proceed to the number or the element to search for, which in this example has the number we are searching for is 0, 2. And as you can see, the baggage ID number 0202 is found in conveyor 2. The next sample test consists of 1, then the number of conveyors, which is now 2, and the length of the conveyor, which is 3. Now, let us enter the baggages for conveyor 1, which is 11, 12, and 13. Now for conveyor 2, we have 21, 22, and 23. Now we're going to search for the element. However, in this case, based from the Leon's file, we are going to search for the 99th number. And as you can see from the elements that we inputted, that there is no 99 in both conveyor 1 and conveyor 2, which results into baggage ID number 99 is not found in any conveyor.
Let us now move on to the examples. First, we're going to need at least 5 test cases. So that's we're going to input 5. Now we're in test case 1. Let us now enter the number of conveyors, which is 2. And enter the number of conveyors, and enter the length of the conveyor, which is 3. So for conveyor 1, we're going to enter 1, 2, 3, 4, 5, 6, and 7, 8, 9. For conveyor 2, we're going to add 9, 8, 7, 6, 5, 4, and 3, 2, 1. Now we're going to search for element that is in conveyor 1 and conveyor 2. We're going to search for 4, 5, 6. And as you can see, that baggage ID number 456 is found in conveyor 1, which concludes that test case 1, 456 is found in the list. Now let's proceed to test case 2. We're going to input the number of conveyors, which is now 3, and the length of the conveyor, which is 2. Let's add 1, 2, and 5, 6. Now we have 3, 4, and 7, 8. And lastly, we have 6, 7, and 9, 0. Now we're going to search for an element that isn't in the list. So we're going to search for 89. And as you can see, baggage ID number 89 is not found in any conveyor, which concludes in test case 2, 89 is not found in the list. Let us now proceed to test case 3. We're going to input the number of conveyors, which is 4, and the length of the conveyor to 3. To make this much more quick, we're just going to add 1, 4, 5. Then we're going to do the same. 2, 6, 7. Now 3, 8, 9. And lastly, 9, 8, 4. Now we're going to search for an element that is in the list. We're going to add 4. And as you can see, that the baggage ID number is found in conveyor 4, which concludes in test case 3, number 4 can be found in conveyor 1, and it can also be found in conveyor 4. So let us move on to test case 4. So the number of conveyors can now go to 5, and the length can now go to 1 to make it much more easier. For the first conveyor, we're going to add 206. For conveyor 2, we have 897. For conveyor 3, we have 674 by 675. For conveyor 4, we're going to have 342. And conveyor 5, we're going to have 001. Now let us search for an element that isn't on the list. Let us try to find 690. And as you can see, Baggage ID 690 is not found in any conveyor, which concludes in test case 4, number 690 is not found in any of the conveyors. Now let's move on to test case 5. We're going to add the number of conveyors, which let's say 3, and we're going to add the same number 3. Now let us add 111, 112, and 113. For conveyor 2, we're going to add 221, 222, and 223. And lastly, for conveyor 3, we're going to have 331, 332, and 333. Now we're going to search for an element that is in the list of conveyors. We're going to search for 222. And as you can see, baggage ID number 222 is found in conveyor 2, which concludes in test case 5, 222 is found in the list.
Now moving on to the second problem. This time we will use binary search. Binary search, contrary to linear search that examines the elements one by one, this searching algorithm searches by half. It will divide the array in half, then checks if the target is in the left or right. The search method for binary search will look like this. First, we will set a boundary for left and right, then move on to the loop. The loop will find the middle of the left and right boundary. Checks if the middle is equal to the target. Compare that middle to the target to find out which boundary to use. Then, if the last element is not equal to the target, the program will return -1. The creation of array is similar in the linear search, except it is not a 2D array, so the parameter will only be the size. The main function is almost also similar to the linear search, with the prompt of test cases, the dimensions of the array, and the search. You just need to take account that the array is no longer a 2D array, so the program will not ask for the rows and columns. So, without further ado, let's try operating the code.
Now let us try to run our code. We're going to enter for test cases 3 so that we can continue after this example. Now, in test case 1, we're going to enter the number of gadgets, which is 5. This indicates that we have 5 different gadget prices that we can enter in this line of code. Based from the Leons, we're going to input 1000, 1500, 2000, 2500, and 3000. After we enter that, we are now going to search for the gadget price. In this example, we're going to search for 1500, and as you can see within the type we just entered, 1500 is available, which concludes in test case 1, 1500 is found. Now let us move on to test case 2. We're going to enter 4. And in this example, we're going to input 4 different value prices that are 1200, 1500, 1800, and 2100. Now we're going to search for the gadget price. In this example, we're going to search for the number value of 2000. However, and as you can see before, there is no 2000 that we inputted, which means that 2000 is not available, which concludes in test case 2, 2000 isn't in the list. Now let us move on to test case 3. we're going to input the number 3 for the number of gadgets, and we're going to enter the gadget prices, which is 500, 800, and lastly 1000. Same as before, we're going to search for the price of the gadget, and in this example, we're going to search for the number 800. The same results, 800 is available, which concludes that in test case 3, 800 is found. And since we are at our test case 3, there are no more inputted test cases given, and the program stops. So, we're going to need four test cases. That's why we're going to enter the number 4. Now, we're going to enter the number of gadgets, which will say 3. We can add 3 different values that have any integer. So, let's add 300, 400, and 500. Now let us see if 600 is within the gadget prices. And as you can see, in test case 1, we have 600, which is not available and is not currently on the list. Let us move on to test case 2. Enter the number of gadgets, which is 5. We can enter 5 different values of integers. Let's say 100, 200, 300, 400, and 500. We're going to search for a gadget price that is in the list, which is 300. And as you can see, 300 is available, which concludes our test case 2, that 300 is available. So, let's proceed to test case 3. We're going to enter the number of gadgets, which is 6. We're going to enter 1000, 2000, 3500, 4000, 6000, and lastly 7800. Now let's see, and we're going to search for a number that isn't on the list, which is 600, 6001. Therefore, 6001 is not available, which concludes test case 3, 6001 is not on the list. Now let's move on to test case 4. Let us enter the number of gadgets, which is 2. Let's say the numbers are 21,000. Next, we have 32,000. We're going to search if there's a 32,000. And voila! We have 32,000 in our list, which closes our test case to 32,000 is available and is currently on the list.